So now I'll be talking about Hilbert Transform. Hilbert Transform is a very important thing, and it is also known as 90-degree phase shifter. So how does it work? It is a simple signal which is passed through a Hilbert transform HT, and we get X cap T. So what is this HT that makes it into X cap T? HT is 1 upon pi t. So what will happen? Xt getting multiplied with 1 upon pi t getting convoluted with it. Whenever you have an LTI signal, it will get convoluted, but in the frequency domain it will get multiplied. So some of the basic things that you know about 1 upon pi t is that it is linear time invariant system, first of all, LTI system, so therefore the convolution will take place. And the other important thing is that it is non-causal system. Non-causal, I always make mistake in this, that I consider it as a causal system. So it is a non-causal system. Now after converting, let us convert it into frequency domain and check out what is really happening, because you can't determine what is happening, you can't know what is happening when you are working in the time domain, because you can't have the graphical view. But when you convert it into frequency domain, you can very easily have a graphical view of it and understand what is really happening. So let xt have a Fourier transform into x of f, and ht has a Fourier transform of h of f. You can find xf in any way, like taking a Fourier transform, or you might know its Fourier transform. But for ht, which is 1 upon pi t, you can determine the Fourier transform very easily. You all must be aware of one thing, that for a signum function of t, all of us must remember this. This is a very important Fourier transform. It is 1 upon j pi f. Signum t is equal to 1 upon Fourier transform signum t is 1 upon j pi f. Applying duality theorem. What duality theorem says, if you write it here with t 1 upon j pi t, you can write this with a minus sign in the frequency domain. So I'll keep 1 by pi t here, move j here, and there's a basic property of signum function, that signum of minus f, it is an odd function, it is minus j signum function of f. So you get the Fourier transform of Hilbert transform. So two things you need to remember is Hilbert transform in time domain. Is 1 upon pi t, and in frequency domain is minus j signum function of f. This is clear. So how to write minus j signum function of f? This is signum function of f, but if you multiply it by minus j, what will happen is it will reverse. So it is a minus 90-degree phase shifter, plus 90-degree phase shifter in the negative part, and it is plus minus 90-degree phase shifter in the positive part. So if any signal that passes to a Hilbert transform get 90-degree phase shifted. So if we have a cos signal, if cos signal will get converted into sine signal because of 90-degree phase shifting, sine signal will get converted into cos signal because of 90-degree phase shifting. And you can also write, like, if you don't want to convert it like this, you have any signal, you can, what you need to do is, like, let us assume a simple cos signal like AC cos omega ct. What will happen to this? You can write it at AC cos omega ct minus 90-degree. Okay, so I'll tell you some of the basic properties of the Hilbert transform. Properties of Hilbert transform. Some of its really simple properties include that Hilbert transform, for Hilbert transform, energy and power remain same. Like if you have xt and x cap t, for these energy slash power remains same. So if you are asked that you have a signal, you pass it through a Hilbert transform, you convert sine into cos, you pass it to a 90-degree phase shifter, anything like this is done, the energy and power remains same. Always remember this. And sine will get converted into cos, cos will get converted into sine. And the other important thing that is used a lot is that if you take Hilbert transform of xt, you get x cap t. If you again take its Hilbert transform, you get xt but with a negative sign. So if you need to change the magnitude, reverse the magnitude, reverse the amplitude, you need to do anything of this sort, you need to take its Hilbert transform twice, and you'll get negative or xt. And the other important thing is that xt and x bar t are orthogonal. What is the meaning of orthogonal? What is the meaning of orthogonal? Like in simple language, these are perpendicular. But how do you show that these are perpendicular? You multiply these and integrate throughout. Like xt, x of t into x bar of t will get you a 0. So a 90-degree phase shifted version, which is orthogonal, will always give you a 0 when you integrate its product throughout the range. The other important thing is that you can find Hilbert transform for various things, but most of the useful part of it is mostly for a rectangular function, passing through a rectangular function, like things like that. For example, you have force sink. I'll show you with the example force sink 40. So this is a sink function. You pass it through a Hilbert transform and you get a yt. So what you know here is after passing through Hilbert transform, and it is generally asked that what will be the power of the signal, what is the energy of the signal. So when this question came in ISRO, everyone got confused, like they were taking the Hilbert transform, taking 90-degree phase shifter. But you need to remember the property, like according to the property, the energy and power will remain same whether you do Hilbert transform or not. So how to find its energy or the power? It is very easy. You all must know that the energy and power of signal can be calculated. It can be converted into a rectangular signal, and after converting into a rectangular signal by taking a Fourier transform, you can find the area under the rectangular function. Okay, I think all of you must be clear of it. I'll do a proper question session for this. Therefore, I'm not explaining the questions in detail. I'm just telling you how these concepts are being used. In a question drilling section, I'll tell you all the questions that are necessary for your preparation. It will include the previous year questions, it will include everything. And in the next video, we'll study about pre-envelope and convex envelope.